Alright, so for this part, we are going to go over the store procedures I've created. A majority of the store procedures I've created are used in the Power BI report, but there are a couple of them that I don't use, and their purpose was for me just to try new things out or create different store procedures. So we're going to go through each and every one of them. Some of them will take less time to explain, but this section shouldn't be too long. Okay, so for the first store procedure called all stock raw data, this store procedure is basically a select all statement coming from our overall stock table. As of recording this video, that table has around 700,000 rows. So that is a lot of data coming from one query. And especially since we're running it as a store procedure, it's going to take a little bit longer than having a regular select all query. You can also see we have a variable or parameter set up to where we could put in a certain stock symbol, and it's going to retrieve all the days that stock symbol was traded. In this example, we have the stock symbol of DFS, and that stands for Discover Financial Services. So this table has 3,400 rows, and it's going to give you all the rows that Discover traded. So the next example we'll take a look at is Tesla. But on a quick side note, I do want to mention that these store procedures are not going to be too complex. And for the more complex one, we're going to go behind the store procedures to see the coding for it. And as I mentioned earlier, this store procedure here is basically using a select all statement where the stock finder is equal to the stock symbol in our overall stock raw data table. So you can see that when we put in a parameter for the stock finder, that the store procedure actually runs pretty quickly, ranging from anywhere between 2 to 5 seconds. But you can see here in this example that we are running that store procedure now without the parameter, and we have already reached over 20 seconds on this store procedure. So as I mentioned earlier, this table contains over 700,000 rows, and it's going to keep on growing as we add more stock symbols and as the day passes. Well, that's pretty much it for this store procedure. Very simple and nothing really too complex for it. The next store procedure we are going to look at is called all stock raw data 1 week. And the data is coming from the 1 week stock data table. And you can see here that the parameter you don't have to put in, just like as the last store procedure we ran. If you don't put in nothing, then it's going to return all of the stock symbol information. So for this example, we're going to go with Discover again. This store procedure doesn't take as long as the previous one, mainly because the table that we are using in the store procedure uses a lot less rows. Also, you can see that this query executes pretty fast, taking only a second. And we're going to take a look at what the data output looks like, or the data set, when we do not specify a parameter. And you can see that the store procedure runs quickly with only 14,000 rows in this data set. So it's substantially less than our previous store procedure. And this one, in the long run, or maybe logically speaking, depending on how you want to view your data, maybe at a recent period, this store procedure may be a little bit better. The next one, called all-time stock history, is not one that I really use, so we could skip over that one. That one is basically the same thing as our first store procedure, all stock raw data. With that being said, we can move on to the next store procedure, and it's called current fidelity benchmark. This one is basically an overview of the fidelity benchmark table that was scraped from Python for the current day, or for the day this table was imported from SSIS to our SQL database. So on to the next store procedure, and it is called Daily Stock Performance Query. And this store procedure is basically an overview of how each company performed in the stock market for the current day. So you can see we have the stock symbol, the stock name, the sector, sector last when it was updated, the stock close open difference, the percentage from that, and then we have the open and we have the close. So this data set is going to give you an overview of how the stock market performed in the day. Well, for the sector and for the companies that we have in our original stock symbol data list. I don't use this store procedure in any of my Power BI reports only because I did the join incorrectly, and now looking at it, it should be a full outer join instead of an inner join. And the reason for this is because not every stock symbol was found on the Fidelity website. So when we go to look at our data set, we may have those 6 to 8 stock symbols missing because the Python script was not able to find it on the Fidelity website. Let's look at this query and see what exactly it does. So the first thing we have is our select statement. We could avoid all of the coding above. This is just basically the coding that you see when you go to modify the store procedure. So the first thing we have is, of course, the stock symbol name. We have the sector coming from the Fidelity benchmark table. We have the last percent change coming from the Fidelity benchmark table as well. We are then going to perform a couple of calculations, and the first one is we are going to look at where the stock symbol closed, or excuse me, where the stock symbol opened for the day and where it closed, and we are going to get the difference between that from that. So you can see we are going to use the round function, and then we are going to take where the stock symbol closed, subtract it from where that stock symbol opened, and so that'll give us our column named stock close open difference. Not the best naming convention, but for now it is what it is. And then for our next column, we are going to take where that stock symbol closed for the day minus where it opened, multiply it by 100, and then divide it by where that stock symbol open for the day, and that is going to give us our percentage of how much that stock symbol for the day increased or decreased. So the round function is only going to show 2 decimal places. Then we move on to our from and our join section, and it's kind of self-explanatory. It's just that we're bringing multiple tables together so that we could grab and combine information as one. But I want to focus on the where statement next. So we have where stock history dot date, that is our column, is equal to the date for today. So we are going to use the convert function to convert the get date function into a date format, and it's going to only do it for the current day that the get date function returns. So in our case 1217, the output should be 1217 coming from that function. And we have another requirement, and it's where the stock open is not equal to 0. And the reason for this is because the calculations that we performed earlier, if there's a 0 in the open column, then we can't perform that last column, the percent change, because you can't divide by 0, and we get a SQL error. Moving on to the next store procedure, it is called EOD stock information, or end of day stock information. This store procedure is going to show you the rows where the company or stock symbol had data for the current day. The next store procedure I want to look at is called stock decliner. Think of this as a subset of our daily stock performance store procedure. And basically, as the name says itself, it's only going to list the companies that had a negative day in the stock market for that current day. And this store procedure is its own query. It doesn't connect to the other store procedure, which is the daily performance one that I mentioned earlier. Next up, we have stock dividends, and this, of course, is only going to list whenever a company paid out a dividend and the information behind it. This is another store procedure that is used in the Power BI report as well. And we're going to quickly take a look at this store procedure too, because there's a join I want to show you, and it's the correct join. So if we go to modify, we get what the query looks like behind the store procedure. And as you can see right off the bat, instead of using an inner join, we are going to use a full outer join. So we're going to get some values that return null for the sector and industry, but that is fine with me. I still want to see everything. And you can see we also have a where clause where the dividends column is not equal to 0. So that would mean, that would assure us that that company had to pay out a dividend for that day. So right after that store procedure, the next one we could look at is called stock gainers. And this is going to contain all the companies that gained in the stock market for that day. We have the open, the close, how much they gained in dollar value, and their percentage gain. And all of this is for the current day as well. So basically, it's going to be the same thing as the decliners. It's just that there is several columns that are not included in this store procedure. But there's not really that much of a worry there. Next up, we have the stock news search, and this is going to retrieve all of our stock symbol headlines with the article link that we pulled from the web using Python earlier. So if we take a look at the output, you can see we have our stock symbol, the headline, the link, and the date it was published. So it looks exactly like that Excel file we was dealing with earlier. The next store procedure is called stock percent change year period, and I definitely could have named this better, but for now it is what it is. So this is one of the more important store procedures that I created, and the query for it takes several seconds, well, not even several seconds. It's going to take about anywhere between 30 seconds to about 2 minutes because there's a lot of calculations in the background. So just to give a quick overview of this store procedure. So in its simplest term, this store procedure is going to look at the average closing price compared to the next year, compared to a 5-year period, and compared to a 10-year period. And it's going to output the result as a percentage. And we're going to go over this query too, but I want to show you what it looks like first. So all these numbers, when you look at it this way, it's going to be confusing. And we use this output or data set in our Power BI report, and it becomes a lot more clear once we see that information. But let's take a look at the query itself, and it's a little bit long and complex, but it repeats the same pattern again for each year, for a 1-year period, 5-year period, and a 10-year period, but I will definitely explain it to you. So I'm going to try and explain this to the best of my abilities. So the first thing that we have here, we are going to select the distinct stock symbol, then the stock history date. This is our overall stock history data. We're going to pull the date. We're going to format it as the year as well. And we are going to use the min format just to retrieve one date record. So as you can see here, we are going to have many dates within a year, but because of that, I just only want to select the minimum one and then output it as the year. Then we are going to use the average function and get the average for the stock symbol closing price. and it's only going to be for that specific year as well. Okay, so here is where it gets a little bit more complicated. So now we are going to use the lead window function, and we are going to get the average for the stock symbol closing price again, and it's going to be partitioned by the stock symbol and the year, or our date, which is formatted as the year. And because we are using 1 for the lead function, it is going to look at the next row. And this is going to be our next year average close, or basically a year over year period. Then the next column, which is called stock year change, is going to look at those two previous columns we created and subtract them both. And this is going to give us the dollar value in that. And then for the next column, we are going to calculate the percent change from those two columns we calculated earlier, where we had the average closing price and then the next year average closing price. And because some of the companies, when they first started trading in the market, started at $0, our closing price for some rows may have a value of 0. And so in order to avoid this, we are going to use the null if function. Using the null if function allows this whole store procedure to even work. And with that being said, since we looked at it at a year over year period or 1 year period, we are then in that next block of coding are going to take a look at it at a 5-year period and a 10-year period as well. So now that we've covered that, we could take a look at the rest of the query. We are only going to be using the stock history table, and then where the stock symbol history equal the stock symbol history, those two are just basically going to equal each other. And then we're going to group it by the stock symbol and the date, which is going to be outputted as a year. And then it's going to be ordered by the stock symbol and our column called test date. And this is a output of our store procedure. All right, so to make this a little bit more clearer, I'll start with the first row that we have and walk you through the process. So we have our test date, and I name it test date because I was testing this store procedure out, or this query out, to see if I could get it to work, and it ended up working. So our test date is called the year, but in any other case, I would actually go back and change this to have it be named the year column. But for right now, it is what it is. So let's start with the first row. We have American Airlines, which is AAL, and you can see that their average closing price in the stock market for 2005 was $27.40. And in 2006, it was $41.78. So if you look at the first column, or excuse me, the third column, where it says stock average close, this is going to look at the closing price for that specific year. So American Airlines, it was $27.40 earlier, that I mentioned earlier, excuse me. And then in the next column, where we use our lead window function, it is going to retrieve the next row. So we are still looking at that first row, but in our next column, which is called next year average close, it is going to take the value that is in the second row, which is the average closing price for American Airlines in 2006, and output that as a value. So now that we have those two values on the same row, we could basically or simply subtract them from one another. And you can see when you do 41 minus 27, you get a increase of, or a difference of $14.38, with those numbers being exact. And then from those two columns earlier, the stock average close and the next year average close, we could get the percentage that they increased or decreased as well. So continually looking at the first row, you can see that American Airlines from 2005 to 2006 in a year over year period increased 52%. And we basically repeat this process for the 5 and 10 year period. I won't show the whole output because it could kind of get a little bit overwhelming. But if you look at the 5-year average close, you can see that it's going to pull the value in the first or the third column, excuse me, stock average close from the year of 2010, which is $8.14. And when not enough data is supplied, we get the value of null. So if I scroll over to the right a bit, you're going to see that we have several null values. And in row 6 is the year of 2010, and currently we are in 2020. If we look at the next row, which is row 7, and it's the year 2011, you can see that there are null values because we haven't started the 2021 year yet. So once we enter 2021 and we have data or information for 2021 for a particular stock symbol, this store procedure will update as well, and it will remove those null values. And like I mentioned before, looking at this data set like this can be very confusing to the eye. So we actually have a visualization in Power BI that makes this information a lot more clearer. And when we come across that information, or that visualization I should say, in Power BI, I will definitely let you know which one it is. And one more thing as well, the null values do not only appear in the 10-year period, it also could appear in the 5-year period as well, depending on when the company first publicly traded in the stock market. So the next store procedure I want to take a look at is called stocks not found in Fidelity. And just like its name says, coming from that Python script, it is only going to retrieve those companies or stock symbols that were not found on the Fidelity website. Once more, we are going to use a full outer join, and then we are going to specify where the stock sector stock symbol is null. And this is going to return all of our rows for where it is null in the stock sector table. That is another store procedure that we use in a Power BI report as well. The next store procedure, which is called yesterday's stock information, is basically we're looking at the same thing again as we did with several other store procedures, but we're looking at the data from yesterday. I don't really use this one in the Power BI report, but it's very helpful for whenever I need to take a look at a particular stock symbol and the current day has already passed. So I could quickly run this store procedure and I'll get yesterday information if the new data has not been updated yet, or if I want to look at yesterday information. The last store procedure we're going to take a look at is called stock performance search, and you can see that there are two parameters. You could use the stock finder, which is basically the stock symbol, and you could use the date you want to take a look at the information. So in our example, we have discover and the date of September 16th, in the year of 2020. And you can see the stock symbol, the name, the sector, the industry, where it opened, where it closed, and the latest date. And I named this column, I renamed it in the store procedure. And on a side note, one thing I want to talk about for several of these store procedures, and this one in particular, I could not figure out how to enter in multiple values for one parameter. I tried a lot of research in different methods I think might work, but unfortunately I couldn't get that one to work. Like, let's say for stock finder, if I wanted to look at Tesla and Nike stock for that day, I couldn't figure out a way to do it, so I just had to go with one value parameters. But other than that, that's basically it for the store procedures I've created. And again, mentioning that these store procedures I just created on my own. I came up with different ideas I wanted to look at. I tried to come up with some queries that may be challenging to build, but still obtainable to do. Basically with the overall goal in mind of trying to replicate a real life work scenario, but using stock information. So instead of writing long queries out each and every single time, we could basically use a store procedure and we'll be good. Alright, for this part, we are going to go over our database, the tables in the database, the columns, and the relationship, as well as the relationship diagram. So the database that I use to have the data updated every day, Monday through Friday, is called stock underscore test. I know you see stock underscore data, but this is like a bit of a testing database for me. I don't use stock underscore data in any of the Power BI reports. As I mentioned earlier, I basically use it to try out new things, whether that be running new queries or importing new data. So our tables are date table, fidelity benchmark, GDP data, predictions, stock history, history 1 week, stock name, stock news, stock sector, and we have several views as well: stock performance, end of day stock data, machine learning data, and sector performance. Now, some of these tables I don't use in the Power BI report, and I'm going to go over that as well. But the first table we have here is the date table. And the date table is basically going to contain all of our date information starting from 1816 to the year 2025. On the left hand side of the screen, under the columns folder, you can see all of our columns, the data type, and whether or not that column is a primary key. So the date underscore month is a primary key in this table, and you can see it is listed under the keys folder as well. The date or the date underscore month column could have been, either one of them could have been primary keys, but I just decided to go with date underscore month. The next table we will look at is called fidelity benchmark. And this is basically our fidelity benchmark table that we scraped from the Fidelity website with Python earlier. As you can see on the left hand screen again, we have the column names and the data type for each column. We can also see that the primary key in this table is the sector name. There is one thing I do want to mention about this table and the way it gets updated. Because this table does not contain date information in the rows, but time periods in the column, there has to be a special way we update this table. If we try to update this table by simply importing the latest data into this table, we would be breaking our primary key constraint because we would have duplicates in the sector name. To take care of this, I created a script that removes the primary key and foreign key constraints from this table. Then it is going to completely wipe this table so that this entire table is clear. And then at a certain time of day, when the SSIS program gets ran and updates the data, that's when this data is imported. And then later on, those primary key and foreign key constraints are then put back into place with another script ran after the SSIS program has been ran. And I will show you the SQL agent job that does this whole process automatically for me when we get to that point. But the next table up is the GDP data table, and we've seen this table before. Basically, it's going to contain the year, the GDP for the United States, and the GDP for the entire world. The primary key on this table is the year column, and it's going to connect to our date table that we seen earlier. The next table that we have is called the predictions table. This table I don't use. I was trying something out in this table and just to see if it worked, but this table I don't use at all. There's another table in our cube database that I actually use in our Power BI report to get those predictions. The issue with this table here is that it only shows me a prediction one time and that's it. In our cube database, I could see predictions up to a couple of months or even several years if I wanted to. The next table we are going to look at is called the stock history table. This table makes up a majority of our data in our entire data set. It contains over 700,000 rows and it's going to contain information for each and every stock symbol that traded on a weekday or whenever information for that stock symbol was available. The thing about this table is that it does not contain any primary keys, but its foreign key is the stock symbol column. We could have created a composite key for the date column and the stock symbol column, but for how it works now is perfectly fine with me. And then looking at the stock history 1 week, this table contains a lot less data, but you're basically seeing the same information from our stock history table. And again, it's only going to have the foreign key of the stock symbol. Moving on to the next table, we have stock name. This table we've seen many times before. It's going to contain our stock symbol and the company name behind it. Nothing really more than that. But the primary key in this table is the stock symbol. Next, we will look at the table called stock news. And again, we've also seen this table as well. It's going to contain our stock symbol, the headline, the link to the article, and the date the article was published. As well in this table, we do not have a primary key, but we have two foreign keys. The foreign key is the stock symbol, and the next one is the published column. For our last table, we have the stock sector. A very simple table here. Again, we have the stock symbol, the sector it belongs to, and the industry it belongs to as well. We do have a couple of keys in this table. The primary key is the stock symbol, and the sector is the foreign key. Okay, so now it's time to take a look at our views. So I created several views, and they serve multiple purposes. One of the purpose of the views I created here was to get a better understanding of what views exactly are. Because I'm going to be the only one looking at this database and I don't have other users attached to this database, the views here aren't really of utmost importance. But they did help me understand of what exactly a view does. But in our case, it doesn't really matter. But there is one view I want to go over that I found to be very helpful for me. So the current view we are looking at is end of day stock data. This is basically the end of day stock data or the current stock information. But the view I want to take a more closer look at is called machine learning data. So when I created this view, there were a lot of joins in place to try and connect all the tables together so that I could then use it in the SSAS tool to create stock closing price predictions. So the query is still running and it's still retrieving rows, but this table is going to combine the overall stock history table with the fidelity benchmark table. Then this view gets used in SSAS to create our closing stock price predictions. Now, those predictions in SSAS, for me, last time I ran it, took around 2 hours, and that was with all of the data imported. So this creating the predictions can be a lengthy process, even when you don't make a lot of modifications to the model. But we'll come across that path when we reach the SSAS section. Next up, the last view that we have is called the sector performance. And this is basically the same thing as the fidelity benchmark table. So it's really nothing special there. And as I mentioned earlier, the views were more so for me to get a better understanding of what views actually are. Okay, so now that we've completed the view section as well, we could take a look at our database diagram. So on the screen, you can see all the relationships that we have between each and every table. And before I created the database diagram on SQL, I drew all the tables out and created the keys myself on paper. So that way, when it came time to create these tables and creating the relationships between them, I had a pretty good idea of what I needed to do. Also, it saved me a lot of time from me trying to figure out on the fly all the tables and the connections that needed to be made. So, drawing out all the data sets that we had and then creating the keys for them on paper saved me a whole bunch of time. Alright, so we're going to take a look at the SQL Server agent. From my knowledge, this allows you to create a job and have that job ran automatically. Within those jobs, you could write out SQL scripts. You also have the ability for the jobs to be ran at a set time schedule. And this is something I didn't even have planned when I was writing out this whole project. It's something that I actually came across because I was trying to automate the process of updating the tables in our database. Although I do not use SQL Server Agent to do that process, I actually found it to be useful in another case, and we're going to go over that now. I do want to say that setting up the SQL Server Agent was pretty challenging as well. It took some time to get it enabled in the first place, and I had to come to the configuration manager. I've been in this menu before, but not for the SQL Server Agent. There's been times when my SQL Server would not start and I would have to come here and automatically or manually start it. But for the SQL Server Agent, I had to do the same process, but there's a couple more steps to where you have to specify which login you want to use in order to actually get it up and running. Not only do you have to do that, you also have to do a bit of coding to get the mailing system to work as well. So in addition that the SQL Server Agent can run jobs and scripts, you could also send out emails. But if you want to, you have to do an additional step. And that took some time and research just to even get up and running. I won't go over how I got the emails to be set up in SQL Server and then automatically send out emails, but I could give a quick overview. You first have to allow your email to be less restrictive so that SQL Server can contact it, and that way it gives it the capabilities to send out emails automatically. You then have to enable the mailing system for SQL Server and as well enable the SQL Server agent in the configuration menu that I showed earlier. And then after that, you could then write your SQL scripts to use a mailing store procedure to send out data sets automatically. It's a lot easier said than done, and it probably took me several hours over the course of a couple days. And as I mentioned earlier, I did not even have this written down in my project planning. It's just something that I came across and thought it would be useful. Okay, so the first job we are going to take a look at is called deleting fidelity records. And you can see for the description here, it says deletes fidelity records so that the new fidelity data can be imported. And the reason we do this is because we are going to drop every row from the fidelity table and import it with the newest data. And because of that, there's a special way we have to go about this, especially if the table connects to other tables in our database. With this job, we have a SQL script, and this SQL script is going to run from Monday through Friday. But first, I want to show you the coding for that script. Using the agent here to view our T-SQL script is a little bit complex and confusing because they put all of the code in one line. So actually, I'm going to open up the actual SQL script that I wrote and we could get a better look at it. Okay, so we have our T-SQL script open and you can see the coding is a lot more clearer now. So the first thing we are going to do is that we are going to specify which database we are using. This is pretty standard in SQL, and there's another way to specify it. You just have to click on the database in the left hand panel in the Object Explorer and it'll automatically set that database for you. But writing it out to me is the best way to ensure that you're using the correct database. So after that, we have two lines of coding that are grouped together. and they are going to no check the constraints for the fidelity benchmark table and the stock sector table. The reason that we do this is because if we want to delete every record from the fidelity benchmark table, if that fidelity benchmark table has any relationships with any of the tables in our database, we cannot delete every record because we will violate any primary key or foreign key constraints. But in SQL, there's a way that you could bypass this. And using the no check constraint all, what that will do is that will turn off the primary key and foreign key relationships for those two tables, for the fidelity benchmark table and the stock sector table. It'll turn it off and it'll remember those primary key and foreign key constraints. And with those relationships being off, we can now delete all the rows from the table. And that is due to the fact because since we have turned off those relationships, we are not violating any primary key or foreign key constraints. So once we have done that, we can now delete everything from the fidelity benchmark table. Once all of those rows have been deleted, we would then enable those primary key and foreign key relationships. Now, if we were to take a look at the table would be empty. We will only have our columns. But when we run our SSIS package, the data will be updated and this table, the fidelity benchmark table, will be populated again with the right primary key and foreign key constraints. And we do this because we need to delete rows from a specific table that has a relationship with other tables in our database. So now that we've gone over our T-SQL script, we can look at this schedule for this job. And you can see that it is going to occur Monday through Friday at 4:20 p.m. And we started this job back in October on the 26th. And before that, I had the fidelity table, already in our database. But the thing is that the table were not updated. And so I had to create this script to get those tables to delete the record and then populate it with the new fidelity data. So that is it for this job, and we can move on to the next one. The next job we are going to take a look at is called dividends. And we could look at the description for this one as well. So it's going to send the dividends amount, the stock symbol, stock name, and the date it was given out. So every time a company paid out a dividend in our database, I believe every 3 months, we are going to get an email sent to different emails that are my own personal emails, and it's going to send the output as a text file. And we could view the code in here as well. So in SQL or SSMS, you could actually send emails of datasets out coming from a query. Now this also took a bit of time to research and figure out how to get everything exactly I wanted to, and fortunately enough we was able to accomplish that. So looking at the first line of code, we are going to execute the login as the login for whenever I log into our databases or SSMS. We specify our login because I remember a while back I had a couple issues of actually getting the emails to send correctly, and so when I researched the problem, executing as login as the login we usually log in for SQL, this seemed to fix everything or fix a majority of our issues with this script. The next thing, we are going to execute a store procedure. This store procedure is basically like you're sending an email like you would maybe just a regular email or work email. And you can see we have multiple variables that we could use, and I'm going to go over each one in our script. So the first one we have is the profile name. Our profile name is the SQL Server agent operator that we created to get this whole thing up and running. Well, not really up and running, but to give us the ability to send out an email. So our profile name is Alexander Bernard. And this basically means who is sending out the email. So it's basically the from part in the email. Next, we have blind copy recipients. This is pretty cool to me because I didn't even know you could do this as well. Before the finalization of this script, I had it to a variable called to. And when you send out the email, everybody could see who it went to. So when I was researching the different variables you could use for this store procedure, there was something called blind copy recipients. And what this will do is whenever this script runs and send out the emails, nobody could see who else that email went to. But in our end, we could see who this email is going to. So these are my personal emails. I have a couple of them. And whenever this email gets sent out, those people who are on this blind copy recipient list will get those emails, but they cannot see who else received them. Next, we have the subject, and this is basically the title of the email, and we are going to name it as stock dividends. Then we have the body, what this email would contain, and it's going to basically say the same thing as our description. It's going to include dividends amount, the stock symbol, stock name, and the date the dividends was paid out. And then at the end of that email, it just has like a little PS note where it's best, and then it's just my name. Then there's a variable call, or parameter I should say, query. And this allows us to write out any type of SQL query or T-SQL script, and we could use it here. So we are going to specify the database we are using. So we are using stock_test, and we are going to execute our stock dividend store procedure. Then after that, we have another parameter. I should call it parameter from now on, called query result header. Before, when I was trying this whole procedure out, when I would get the emails, the data set would not include the header. So there's a parameter where if you set it to 1, you would have the column headers in the file that gets sent out in the email. After that, we have another parameter called attach query results as file. If you set this as 1, you are going to send out a file with the query results. And then after that, which makes sense, we have query attachment file name. And you can see I have it labeled as dividends.txt. You could also have it in the file format of a CSV and I think a XLXS, which is an Excel file. But for me, the text file was the best method to use. And then we have the last parameter called query result no padding, and that is equal to 1. I don't exactly remember what the issue was with this one, but setting this equal to 1 formatted our text file correctly in the way I wanted it to be. So that is this T-SQL script for this job. And after we go through all of the jobs, I'll show you the emails that I received from our database or from our SQL Server agent. And going to the schedules, you can see that this script or this job occurs every 3 months on the first day. And it's going to run this job at 7:15 p.m. Now the thing about these jobs, if you do not have your computer logged in or if the computer is powered off, these jobs won't run at all. So sometimes I have to remember to have my computer on for some of these jobs, or usually I just set up a display timer to where that the computer is on for 4 more hours after I last touched it. So that way that these jobs could still run without me being needed to log in. Okay, so now we could look at the next job that we have, and it's called stock gainers, decliners, and fidelity benchmark. So this job is a little bit more complex than the previous 2 jobs that we've seen. This job involves multiple steps and multiple T-SQL scripts. You can see the description for it. It sends out which stocks gained or declined. And I should also add the fidelity benchmark table. So you can see we have 3 steps here. So the first step is called stock gainers. And as you may know from earlier in the video or just even by the name, this step is only going to produce the results for the stock symbols or the ticker symbols that have gained in the stock market for the current day. This also uses the SQL store procedure where you could send database mail, and it's going to follow the same concept that we seen earlier, but we are going to use the store procedure called stock gainers, and that's basically it. We change up the subject for it, call it stock gainers. The body is basically going to say end of day stock gainers, and then as I mentioned earlier, we specify which database we use, and then we execute our store procedure, and then we are going to output our data set as a text file as well. And just like the gainers, the stock decliners are going to do the same exact thing, but it's only going to show you where the stock symbols have declined for the current day in the market. So nothing really changed here. Maybe I added 1 or 2 more emails, but it's basically the same thing as the gainers, but change out gainers for decliners, and we are going to output that data set as a text file as well. The last thing that we have is called the fidelity benchmark table job, or the step. Basically the same thing as the previous 2 steps that we've seen. We are just going to execute our current fidelity benchmark store procedure and output that as a file and send it out as an email. After this job is completed, we could then tell the job to quit the job, or we could then tell SQL Server Agent to quit the job, and you can see that here on the last step. And this job gets ran Monday through Friday at 5:15. 5 o'clock is when our SSIS package is ran and our database is updated. So to give it a bit of room, I have it set to 5:15. And you can see the start date for this job was back in June on the 21st of 2020. And there's no end date in sight either. There's also a couple more things I want to mention that you could do with the jobs as well. So you could have alerts. I don't have any alerts set up here, but we could have notifications as well. So after this job completes, I will get an email to the SQL Server Agent operator that I set up earlier, telling me that the job is completed. And you could also have it send you an email whenever the job fails as well. So the next job that we have, and it comes in pretty useful, and I also did a bit of research on here, is called Stock Test Backup Subplan 1. This is just basically going to back up our database the first of every month at around like 10 o'clock a.m. or something. And the biggest thing for me is that I need to have my computer on by that time. So maybe down the road in the future, I may change the schedule of this, but for right now, it occurs the first of every month at like around 10. And this was the last job I created, and this is very important for me because if this database in particular crashes, then I'm losing a lot of time and effort and work put into this database. So it's always good to have a backup at least for each month in my case. So you can see the schedule for this job here. It is going to occur every first of the month at 9 a.m. and we had it set up on the 24th of June. There's also no end date for this one as well. And I do want to mention, I'm not an expert at SQL. This was just based off, researching different things and coming across new features in SQL that I didn't even know you could do, and thought it would be interesting to include it in this project. Although I may know how to write SQL scripts and do all types of different things, this section right here was particularly new for me because I've never done this before. So it was pretty good to include in the project, as I mentioned earlier. So the next job we have is called Stocks Not Found in Fidelity. And I also do want to mention again that this project is not perfect. There's some things that I have to continuously work on to get it to near perfection. But for right now, I think it's a good demonstration to show. So we have these stocks not found in Fidelity. This is basically the store procedure we seen earlier, where on the Fidelity website, when we run our Python script, it does not return every stock symbol. And so in that case, I want to send an email telling me which stock symbols have not been found in the Fidelity website when that Python script was ran. And just like the previous job, we are going to use the store procedure where you can send out an email. And it's basically going to follow the same format, but we are going to execute that store procedure, stocks not found in Fidelity. So this job is scheduled to run Monday through Friday, and we started it back on June the 21st, and it should occur at 5:16 p.m. That's really much it for this job. There's nothing really else to add here. The last job that we have is called the store procedure queries. And as you may guess from the name of the job, is that we are going to run a majority of our store procedures with this job here. This job I just have in here just so that all these store procedures can run, or majority of them can run. So we have 13 steps in this job, and after each step, it's going to go on to the next job until it hits the last one, and then it's going to stop. And these queries, or this job, is ran at 5:14 p.m. and we started it back in June on the 23rd, and it runs Monday through Friday. So I do not get an email for this. This is just running in the background for SQL, and that's just basically it. But I do get an email whenever the job is completed. So there's no data sets being sent out with this job here. And then the last job we have is, I think, a default job that SQL has in here. So we could take a look at our data sets now, or how it looks when it gets sent out in the email form. And as you can see with the operators, you can specify a name that you want to send the email as. So I have it sent as do not reply, but you can still see my email address. So if I were to create a new email address, it'll probably be better for a like Alexander do not reply at gmail.com email. But for right now, I also found this to be a feature and I thought it was pretty cool. So I just decided to try it. So our name in the SQL operator is do not apply whenever we send, do not reply, excuse me, whenever we send out emails. But taking a look at the data set that we have here, this is the Fidelity table. And you can see just as in text format that this table would be very hard to read. So the purpose of this and having these jobs send out different types of data set was to just have something to be automated to where it sends to different people automatically, and they could use it as their own data to plug into maybe some reports that they have or whatever else they would find this data useful for. When the agents send these files out as text, it isn't really meant to be taken at face value. You'll probably have to create a table or a graph with it to get a better understanding of what you're actually looking at. So the next email we could take a look at is the stock decliners. And again, you can see that it was sent at 5:15 p.m. And you can see that we have the open, close, the decline, the percent they declined in, and the date for it. And basically, as I said before, it isn't really meant for you to take at a face value with this text file, but more so to plug in maybe Excel or Power BI and use that to visualize your data. So now we're taking a look at the stock gainers. So in this particular day, it was not too good for the stock market or the stock symbols that I had listed in our stock symbol file list. And then we could take a look at the Fidelity benchmark table again, and you can see that the data is pretty messy here and just have to plug it into some type of software, Excel, Power BI, as I mentioned earlier. And you can see that it's going to be pretty consistent for the most part. You see December 18th, 17th, 16th, 14th, 10th, and like I said, it's only going to run from Monday through Friday. And you can also see this is another email of mine. This is another personal email. And it's the same case with this one here. We get all the emails that we have. You can see the gainers, the decliners, the fidelity benchmark table, and everything. So the only thing missing is that for my personal email that actually sends out these emails, I get an extra email telling me whether the job was successful or not and how long it took to run. But those are a couple of my personal emails that I get data sent to on a weekly basis. And sending out emails do not have to be the only thing. As you've seen before, we can have our jobs also alter tables for us, sort of like a pre-staging process in order for new data to be inputted to one of our tables. All right, so now we are on to the part where we will create our closing price predictions. And just like with any other sections we have previously covered, we need to make sure that everything is installed correctly. So there are a couple things we are going to need. We are going to need to have analysis services set up. So during the installation process of SSMS, you want to make sure that this option is selected as well. The next thing you want to have is Visual Studios, and make sure you have SSAS included with Visual Studios as well. You also have the options for SSIS and SSRS. I would also check those options. Having everything set up properly wasn't really that much of a hassle for me. I've worked with SSAS before in SSMS and in Visual Studios, so most of this was already set up. So with the analysis services, we are able to create a cube database as well as write DMX queries. DMX stands for data mining expression, and the main goal of this for us in our case is going to predict the final closing price. Now we make the predictions using SSAS and Visual Studios, but when we come to the analysis services in SSMS, we are able to predict a longer time period for what we are trying to predict, and that is the closing stock price. So we have a cube database called stock prediction closing price, and this is basically the store procedure where we grabbed our machine learning data from. And to try and explain what a cube is basically sort of like a cube, like the name itself is. But with this in a data warehouse or a database settings, you have totals pre-calculated. So any total you want to look at, it comes pre-calculated. So you don't really have to write out any SQL, or the computer doesn't have to go through any calculations. Like, let's say I wanted to look at the average closing price for a particular stock symbol. That should be already pre-calculated if I'm not mistaken with the cube. Whereas where you write it in a relational database using T-SQL, the computer has to go, or SQL has to go through calculations. But our main goal is to try and retrieve stock closing price predictions from our SSAS mining model. So this right here is the final product of when you've created your predictions using SSAS in Visual Studios. You can come here to the analysis services and run predictions at a 7-day period, 2-week period, and all the way up to a year. I don't think there's any limitations, and this is the DMX I've created. Although I've created predictions in SSAS and Visual Studios, we've never gotten this far to this part where we actually predicted a longer time period, or actually came to the analysis services and wrote a DMX like this. So again, some of this stuff was new to me, but wasn't really too hard to figure out. So you can see here that I actually ran this process all the way back in July. So I believe it was maybe July 9th is when we finished our predictions, and I had the model predict up to a 7-day period. But we are going to run an example where we predict for a full year. I don't think we need to process our mining model again. You could basically, in the part where it says predict time series close, comma 7, you could change that out with whatever number you want, and that will represent the days. So if I put 360, we are going to get a full year. So the query is executing, and you are going to see the stock symbols for each one run up all the way up to a full year. So before we had it at a full week period, but now you can see we are in the year of 2021. And with this DMX query, we are also able to use it in Power BI. So we could connect to our analysis service engine and then have this query ran, and we will get the same results, and we could visualize that data in Power BI as well. But I'll show you the steps it took to actually get to this ending point. So we are in Visual Studios right now, and I do want to mention that before coming to Visual Studios, I tried to create predictions using Python, but I wasn't able to successfully do it. But then I remember that I actually created something predictions similar to this when I was back in school. So I thought Visual Studios would be a good alternative option. It was probably the best option in the end as well. Although I use Python for different algorithms, the algorithm I was looking to use, which is the ARIMA model, I wasn't too familiar with that one. So there's a lot of variables you can put in functions. A lot of things have to be correctly done in order to even get it to work. And especially since I'm dealing with a huge data set, a lot of things could go wrong and I may not understand the code to the fullest. So coming to Visual Studios and using SSAS was a little bit more up my alley. Okay, so our solution or project has finally opened. And you can see the first thing we are greeted with is a data source view. Whenever you start a new project using Visual Studios in connection with SSRS, SSAS, and even SSIS, you are going to need to connect to a data source. Our data source in our case is a database which we have seen before, and it's called stock test. Then from that data source, you need to create a data source view. This is basically what you want to pull from your data source. So our data source view is going to allow us to only retrieve specific information. So when we run our algorithms, we are not including information that is not useful to us. So you can see in our data source view, the only thing we have is our store procedure, which was called the machine learning data. But I could quickly go through and show you what adding and removing tables look like. So all you would have to do is just right click on the empty pane and it'll give you a list of options. You could write a query, you could add tables, create a new relationship for the tables you already have in your data source view as well. So you can see once we click the option to add or remove tables, we are greeted with a list of tables and even store procedures as well, or views, excuse me. I know I call machine learning data a store procedure, but excuse me, it's actually a view. So that is our only table in the data source view. So now that we have that, we can create a new mining structure. So a mining structure is basically what type of algorithm you want to run. And thankfully with Visual Studios, they give you a graphical interface of the different types of models you can run, how to set it up, and more options as well. So the first thing we have, they ask you, do you want to choose from a relational database or a data warehouse? Then they ask you which data mining technique do you want to use. So these are the different algorithms you can use. Some of these algorithms I worked with in Python, but some of them I haven't. So the algorithm or the data mining technique we want to use is Microsoft time series. Logistic regression was my initial thought way back then, but then after some research, time series seemed to be the better one. And you can see from the description, it tells you that any data that is time related, such as sales data or yearly profits, is best for this data mining technique. Quickly moving through the steps, you can see our data source view. and it is called machine learning data. So we've already went over that, and we are going to select that view as our case. And then from here, we could select all the columns we want. We could also declare which column would be an input and which column would be the predicted value. So the input is basically like the independent variable, what we are plugging in effect to the result of the dependent variable. So basically all the columns here except the closed column will be our input. It's a reason why we have this view created. So the closed column will be the predictable, and then you also need to specify a key. The key in my case was the stock symbol and the date. And on top of that, Visual Studios, or the data mining wizard, can also help you suggest which columns are most influential on what you're trying to predict. So once you have your dependent variable selected, it'll give you a suggestion on which columns are most influential on that dependent variable or what you're trying to predict. So right now for me, it took a little too long to run, so I didn't end up running it actually. But you can see it gives you the column name, the score of it from greatest to lowest, and then it gives you the input column, whether it should be an input or not. The first time I ran it, it didn't take too long, but for some strange reason, when I tried to run it again while I was recording this, it was just taking forever to run. It's only going to sample the data, but it was sampling too much data, I guess, and so it never actually produced any results. But that was fine with me because I wanted to use all of the columns that we had from that view. And there are certain ways you go about picking columns whenever you're going to run different types of algorithms. It's not really just one straight shot and you pick all the columns. There's a method behind it, but in my case, I really knew what columns I wanted to choose, no matter if I did the research behind them first. This is just for demonstration purposes and wanted to see if putting different things together would create a useful algorithm. But in most cases, you would not do what I do. You would actually go a little bit further and do a bit more research to see if the columns are highly correlated, or look at a correlation matrix plot as well. Okay, and after that step, you get taken to this page here where you can specify the content type of the column and the data type of the column as well. So continuous means that the number is basically like a decimal, like 1.01 or 1.35, basically values like that. Discrete would mean that the value, I believe, is like a whole number, but then again, you could have it be a data type of a text, and that's what we had with our sector name column. So after that last step, you could go on and process your minor model. But I want to show you what our predictions look like before we go over that process. So these predictions are from the last time I ran this minor model. And when we run it again, I don't really expect it to be any different. Maybe slight variations here or there, but for the most part, it should be the same. So you can see here, we have the minor legend. And then you can see in the background, we have our predictions. So initially, if you do not make any changes, you are going to have all of these stock symbols listed here. So just for demonstration purposes, I removed a lot of them and only selected a few. But you can see these are our predictions, but we want to predict a further time period. In addition to that, we also want to retrieve those predictions and use it in some type of report as well. So let's actually get back to our mining model and process the model that we have. So before we do that, we need to set some parameters for our algorithm or mining model. And you can see that Visual Studios within SSAS give you a wide range of parameters to enter. Now these parameters are based on the algorithm you chose, so different algorithms will have different parameters. So these parameters already have default values listed, But if you come to the screen, you could set up and override those default values. So one or a couple parameters I want to look at is the forecast method. So you can see our forecast method is set to fixed, and for me in my case, I was perfectly fine for that. The parameters also come with a description, so if you aren't too sure what the parameter name means, it'll tell you what that parameter exactly does. So another parameter I want to look at is called the missing value substitution. What this is that if there are any gaps in our data set, meaning that let's say we have a record on January 1st of 2020, and then our next record, doesn't occur until January 20th. How do we want to handle that process? Do we want to use the previous record for all the missing gaps or the missing days between that time frame, or do we want to use the mean between those two values? A lot of the times, each situation is going to be different, and you just pretty much have to use logic on how you want to attack it. In my case, since we are dealing with stock data, and because the values aren't going to be real different from one day to another, I think using the previous method was the best way to go. So to override the default value in the value column for that specific parameter, you just have to type in what argument you want or what value you want for it. This was basically the main parameter for me. Other than that, I left everything else pretty much on its default setting. So after we have fine-tuned all our parameters and everything looks ready to go, we can finally go and process our data mining technique, or our algorithm in this case. So once you click the recycle or process button, you can then run your algorithm and it'll start to run. So when we click run, it'll show you the process progress screen. So this was the biggest thing for me, because when I tried to do this in Python, I wasn't too sure of the progress of the algorithm when I use Python. But here I have a screen, I can see what stock symbol the model is on, exactly what the model is doing, and it's going to tell me everything. And because this process takes quite some time, using Python, I don't know how long, or I can't see if the model is actually doing something or not. So this was a good screen to have, and it allows me to see exactly where we are. So this process actually takes around 3.5 hours to complete. So you can see by the time on the screen, I ran this pretty late into the night or pretty early in the morning at around 2 o'clock a.m. And I just decided to let the algorithm run, left my computer, came back and by the morning time, and everything was done. So this is the second time I've actually ran this model. And because it takes a long time, and also because we have the predictions, you basically only need to run it once. But in this video series, at the end of it, I will add more stock symbols and show you how everything is automatic and how it works. But for this part, I would need to come in manually and do it myself if I want to have those predictions for those new stock symbols. And again, these predictions aren't perfect. This is just for demonstration purposes. So I really wouldn't use these as a huge influencer as when it comes time for me to pick the stocks I want to purchase. And another thing I want to know here is that I'm by far no expert when it comes to processing mining structures in SSAS using Visual Studios, and I'm pretty sure there are methods to decrease the runtime for this mining structure. But the purpose for this was to basically show a demonstration of how I was able to put everything together, or narrowing it down a bit, creating predictions for a stock symbol. So now the whole process is finished. So you can see that we started at 1:47 a.m. and it did not end until 5:34. So over 3.5 hours, very well close to 4 hours for this whole process to be completed. And with that, we can view our predictions that have been created, which we've already seen before, but we could take a look at it again. And you can see the second time that I ran this mining structure that we had a bit of an issue, but fortunately I was able to figure what was wrong. And whenever anything goes wrong, I always come to the configuration manager to see if anything has stopped. And so this was the case here. After I enabled the SQL Server agent for the tabular engine or the tabular database, everything seemed to work fine. And that's another big lesson with this project. When you have all the steps and everything planned out, there's going to be problems along the road, and it's really all about figuring out what is causing the problems and how to fix it as well. So before, when I was trying to get the predictions on this page in the mining model viewer, I wasn't able to because the query was taking too long to send to the server, and I would get a connection timeout. But after we did that, we are now able to get the predictions visually within Visual Studios at this point. So now it's working, and it took a little bit of time to run or send the query to the server. It took about 2 to 3 minutes, but now you can see we have our predictions again. So after we have completed that, we could go back to SSMS and access our analysis services, and we could log in easily. So this is the server name and the server type I use for whenever I log in. So this whole database is not online, it's only on my computer, so I don't really think anyone else could log in. So something I didn't show you before the first time we looked at this screen is that we have our data sources and our data source view. You can create this in SSMS as well, and on top of that you could create it in Visual Studios. But you can see we have our mining structures as well, and you can see we have our mining structure called machine learning data. So now that we have that, we could run that DMX query we had before. So before, if you go back to the earlier portion of the video where I first showed you the screen, you can see our predictions started in July. But now when we run the DMX again, our predictions are from December 25th all the way up to next year, December 25th. And because we have this information, I could then use it in Power BI to have a graph that shows the prediction of those prices over a period of time.